All right, last class, we learned about the law of sines, okay? And today we're talking about the law of cosines. Now, they're kind of drastically different, okay? So don't think that they're similar. And no, there is no law of tangents, so we won't be getting into that, next. This is our last section of the chapter, and we'll review next class and then test the following, okay? So the law of sines. We like to use the law of sines because it's a proportion. I think proportions are relatively easy to solve. When we can't use the law of sines, we should use the law of cosines. Okay? The law of cosines is this. It looks confusing. I will talk you through it. It's a squared equals b squared plus c squared. What does that look like? Yeah, it looks like a Pythagorean theorem, doesn't it? Minus 2bc times the cosine of a. Now you look at that thing and you're like, oh my God, how am I going to remember it? It's not too bad. And yes, you do need to know this for the test. I won't give it to you. Okay? Now if you take a look at this thing, we examine just a little bit. We start with side A, don't we? If I start with A, or whatever side I start with, I need to end with the cosine of the angle that is across from it. Okay, so I'm going to start with, in this case, side A, and then across from it, or excuse me, at the very, very end, I'm going to say cosine of that angle. Now, if I look in between, I have just B's and C's, don't I? Okay, so we're going to start with an angle. Excuse me, I'll start with that again. We're going to start with a side. In this case, it's A. We're going to end with the angle that's across from it, and then everything else in between is just the other two sides. Okay? The hardest thing about this is understanding sometimes there won't be A, B's, and C's, or sometimes our A value won't be the A value. I'll talk about that here in a minute. So if we look at example 1, well, I don't have A, B's, and C's anymore. I got a C, but I've got T's and R's. So understanding, hey, what goes where? Now, it says find the indicated variables. Well, let's cross off T and C, and let's just focus on R. Okay, let's focus on R, and we want to find R. Now, if R is what I'm trying to find, that is what I'm going to start with. Okay, now let me back up a little bit. Can I use the law of sines? Well, in order to use the law of sines, I need a side and an angle. Guys, the way I had this bell ringer set up, that was what we're actually doing today. Okay, so I couldn't actually solve that using the law of sines. And if I look at this one, well, I don't have this side. I don't have this side because I have that angle, so I can't use that. I have that side, but I don't have that angle, so I can't use that. And I have that side, but I don't have that angle. I can't use the law of sines. And now we have the law of cosines to help us out. Now, I think it's a great idea to write our formula down every single time. Why is that? Because it's proven that the more times you write it down, the more likely you'll remember it. Okay? Now, if I'm trying to find R, that is what I'm going to start with. So I'm going to call that R squared. If I start with R squared, then I better end with cosine of R, which in this case is 36. Okay, then the other two sides that I'm going to fill in here as B and C are my other sides that I haven't used yet. Guys, there are two situations when you will use or be forced to use the law of cosines. And it is when you have a side, an angle, and a side. Or if you look down at the bottom of this page, it's side, side, side. Okay, those two situations, side, angle, side, or side, 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 those are when we can't use the law of sines and we have to use the law of cosines. Okay, so now I'm going to use 45 and 52 to fill in for B and C. All right, so I'm going to have 45 squared plus 52 squared minus 2 times 45 times 52. Okay? Any questions about how I set that up?
No. Why did you choose certain numbers for certain numbers? Like,
Yeah, does it matter?
Why did you put the R for A? Like, does it matter?
Yeah, it does. So let me specify. If you didn't hear Brooklyn's question, it says, why did I choose certain numbers for certain things, or how do I know where to put certain numbers? And so I'm trying to find R. Okay, I cross off the other ones just to focus on R. That goes there if we're trying to find a side. Okay, so that becomes our A value, I guess, if you will. The other two sides don't matter. Okay, so I say, hey, I'm going to find R. That's the one I'm going to put for my A value. I know then I need to put cosine R at the very, very end. And then B's and C's don't matter. Does that make sense? Great question. All right. Guys, when you have, if I look at this, I have every single number there, don't I? I've got everything. We can actually just type all of that in our calculator. Just type all that in, making sure we type that in correctly. Go.
2, yeah, the cosine of 36.
Mm-hmm. I'm not going to type this in. What do we get there, guys?
942.8.
What? That's really big.
Yeah. I got something.
That's what I got.
R squared equals what?
942.8.
Brooklyn, nice and loud.
942.8.
Point. Do you have two decimals there?
Just 800.
Okay, 800. Now, the thing we need to understand is that's not R, that's R squared. So what do I need to do at the end? Yep, we're going to square root both sides. And then side R is going to be
30 points. Because there's a 0. Oh, just kidding. 71.
30.7.
30.7.
1?
Yeah.
And probably should put centimeters here. Questions there?
Would you
No.
cut it off if, like, on the test we forgot to put centimeters?
No, no. Now, it does get a little bit trickier than this, okay? And we'll get there eventually. So, example 2. Let's find side L. Okay, again, in this situation, I've got a side angle side. So I'm going to write my formula down. A squared equals B squared plus C squared minus 2BC times cosine of A. So we're trying to find L, so that becomes our A value, if you will. That's what we're trying to find. L squared equals. I'm then going to end with cosine of angle L, which is 104. So times cosine of 104. And then B and C become the other two sides. So 48 and 29 become B and C. Does it matter which one's B and which one's C? No, it doesn't. So 29 squared plus 48 squared minus 2 times 29 times 48. Now, everyone stop for a second. We could type that into our calculator. Okay, we could, because our missing piece of information is right there. But at the thing at the bottom, we cannot type, and the problem at the bottom, our next problem, we cannot just type that in. So I want to talk about order of operations on this one. Okay, if I were to do this with order of operations, what do I need to do first? Parentheses. Is there anything to do inside parentheses here, though? There's not. And then I go to exponents. So here we go. I'm going to do exponents. You guys are going to help me out here. So I get L squared over here. 29 squared. 841 plus 48 squared. 2304. Okay. Now minus, I'm going to multiply these three numbers together. And actually, guys, let me back up here. There's multiplication between everything here, isn't there? Between the 2, -2, 29, 48, and cosine 104. We can multiply all of those together.
Okay.
And actually, no, I'm going to back up. I lied. I want to say it this way. Take -2 times 29 times 48.
84.
2,784 times cosine of 104. If I wanted to multiply by 104, I certainly could. But I want to talk about this. This will lead into the next example very well. What do I do now?
You'd add the 841.
Can I legally add these two together?
Yes.
I can. Can I legally subtract these two together?
Yes.
I can't.
Oh. Oh.
And why?
Because you have to do additions earlier.
Right? Because there's multiplication going on there. So I need to do the multiplication first before I do anything else. Okay? I can add and subtract things together, but not this because it's being multiplied. So now if I take negative 2,784 times cosine of 104, 673, so that's a positive number.
Yeah.
So I'm going to have 841 plus 2,304 plus, what'd you get there again? 6.
673.
And now I've got addition and subtraction, actually just addition all the way across, don't I? So now I can go ahead and just add all those together.
Should we put the squared sign over it? This like thing.
Well, we're going to get there. Yeah, L squared equals this number.
It's 3,818.
3818.51. And now lastly, I need to square root that, right?
61.7.
61.79. I don't have any labels, so we'll just call it that. We agree there with that number?
Yes.
Okay, now I think we would all agree that, golly, Mr. Cole, that's a lot easier just to type it in my calculator. Why are we wasting our time? I agree, but this next example, we have to understand order of operations, what I can do and what I can't do. Questions on these two?
No, I have a question.
Yes, Hannes.
I switched them around and I got 24,555.5.
You switch 29 and 48 around? It shouldn't matter which ones you do. So if you got a different number, I'm guessing we made a computation error. So maybe go back, check our work, but it shouldn't matter where you put B and where you put C, as long as it's 29 and 48 in this problem.
Yeah.
Okay, now example 2. It says finding an angle using the law of cosine. So we can find angles as well. Bad problem because I didn't really specify which angle I want to find. So let's just pick V here. Okay, so if we're finding an angle, our process differs slightly. Okay, we're still going to use our formula, so I'm going to write that down. A squared equals B squared plus C squared minus 2BC times cosine of A. So now, instead of finding a side, we're finding an angle. So I don't know what cosine I'm using. So I'm going to call this cosine V, because that's the angle we're finding. Now, if I'm using cosine V, what side should I start with? Absolutely, the one across from it. So I'm going to call this 4.4 squared. And then the other two sides, 7.1 and 6.7, become B and C. So I'm going to call this 6.7 squared plus 7.1 squared minus 2 times 6.7 times 7.1 times cosine of V. If we take a look at this, guys, now my missing piece is on the right. So I can't just type all that in because it's got a piece that it's missing. So now we have to be really careful about order of operations. Okay, and here's what I'll tell you. We can do that legally in our calculator, just like so. Type that thing in. And I did 4.4 squared, and I get 19.3. Oops, that's not what I want to write with. So 4.4 squared is 19.36. And then we did this in my calculator, or your guys' calculator. What do you get there? 95.3. And we can do this in our calculator. If you want to throw the negative in there, you certainly can. You don't, but you need. If you don't use it, you need to realize that you need to bring the negative down. If you do use it, the negative is in your calculator. So you don't have to. You just need to know that yeah, that's going to be a negative.
Negative 95.14.
Say that again.
Negative 95.14.
Okay, so we can do whatever's in the yellow there together, and then we can do whatever's in the, Ellie, what is that color? Teal? Is that teal?
Cyan.
I like cyan. That's good. We can do that together. Now, here's where mistakes will happen. Okay? If I look at this, I'm gonna write this down. You don't write this down. I'm gonna make this up. I'm gonna make nice, neat numbers. Let's say I've got 20 equals, let's say 12 minus 3 times x. If you take a look at what I just wrote there, it is very similar in its form to this step right here. Would you guys agree? I've got a number with an equal sign, another number minus a number times an unknown. Okay? Now, we would never subtract 12 and 3x, would we? We would never do that. After about 7th grade, we knew that we couldn't do that anymore. Well, it's the same way up here. I can't subtract 95.3 minus, or I can't do 95.3 minus 95.15 because there's multiplication that's attaching those. So how would I solve this guy? You have to do what? I'd have to get rid of the 12 by subtracting it, and then I would divide by negative 3. Same idea. We're going to have to minus the 95.3 from both sides. Oh, we're going to get negative 75.96.
I mean 75.
Yep.
Oh, sorry. I did get that. I don't know why I said 6.
9 what?
9.4.
9 4. You get your 4s and 6s mixed up?
I guess so.
Okay. Now, don't forget this negative sign. This has gone away. This whole thing's gone, but the negative's still there. Negative 95.14 times the cosine of v. Now we're trying to solve for cosine v, so I'm going to divide by negative 95.14. So those will go away. Okay, so in my calculator, you guys might already have some of these numbers in there, but I'm going to do negative 70. And we get that. Now that's cosine, right? Cosine of v. I don't want the cosine of v. What do I want? I want angle v. So how do I get angle v? Inverse. So second cosine. And then I'm going to type whatever that number is, but I'm going to use my second answer button down here that we've talked about, and it's going to throw that answer in. Now I can hit enter. 37.04 is V. So V equals 37.04 degrees. Are there any questions about that? Anything I've done? Especially with that cosine in our calculator, second cosine, second answer. If you have questions, concerns about that, please let me know and I can sit down with you and talk you through that. Okay. Last one, solving each triangle. And again, I'm going to put in here, find all missing pieces. Pieces, P-E-P-I. I wrote it twice, and I was like, that doesn't look right. That's right? Wow. Missing pieces. We're gonna skip that one for time's sake, so you guys plenty of time to work here. So I need to find everything. I need to find angle A, I need to find angle C, and I need to find side B. Okay? Now, like I said before, we will have two situations where we use the law of cosine. We'll either have a side angle side or a side side side. And you can see both of these examples are in both those situations. Now, if I look at this first one, which one should I find first? And the answer is B. Okay? Because I can't solve for angle A unless I know the sides on each side of the angle. Okay? I need to know both of those. So I can find B because I know both sides on either side of angle 63. So we're going to start with B. So B squared equals 29 squared plus 38 squared minus 2 times 29 times 38 times cosine 63. Can I type all that in? I can. Make sure you type it in correctly. And remember, whatever number we get here, we need to do the square root of that number. What do we get there, guys?
35.46.
Do we agree there?
Oh, I only did the square root of 1258. I didn't do the decimals.
Okay, so that'll throw it off slightly.
Yeah.
Again, I think it's a great idea to have a place where we keep all of our answers, so I'm going to call this 35.84. I then need to now find angle A and angle C. So I know that this is going to be 35.84. Okay, so now at this point, I need to find two angles, angle A and angle C. You can pick either one, because if I look at A, don't I have both sides on either side of the angle? And if I look at angle C, I've got both sides either side of the angle. So it doesn't matter. I'll pick angle C. Okay, so if I'm going to find angle C, that is what I need to end with, because that's an angle. So I'm going to say cosine of C. If that's what I'm trying to find, what do I start with? 38 squared. Okay, so if I'm using this angle, well then this is essentially my A value, what I'm starting with. These two are my B and C values. So 29 squared plus 35.84 squared minus 2 times 29 times 35.84. Okay, now let me stop you for a second. I'm gonna backtrack because I forgot to mention something. If I'm trying to find angle C, Could I use the law of sines now? Well, don't I have an angle and a side?
Okay.
So you can, but here's the deal. About 8 out of 10 times, that'll be fine. The other two, there's like a glitch in the system that when you go from the law of cosines to the law of sines, it'll give you the wrong answer. Okay? Once you start with the law of cosines, stay with the law of cosines. Okay? Stay with it. So that's why we're doing it this way. Now, again, I need to find my angle. So, talking about order of operations again, I can do that in my calculator. .38 squared is 1444. What's this whole thing, guys?
This was
2,125.5056.
5056, so call it 51. Yeah. And then I can type that into my calculator. What is it?
2,078.72.
Times cosine of C. Now I'll just subtract these two together. No. Multiplication here. These guys are married together. Okay? So I need to subtract 2,125.51 first. And I'll be left with negative 2,078.72. What do I have left over here, guys?
negative
It's 80 what?
1.
Point. And now what?
It's 0.51.
0.51.
How would it be 45? Don't you have to put it in 44.9?
I don't know. I'm going off your guys' word. Whatever this is. Yeah, I don't like 0.51.
Okay.
49?
I'm not even yet.
Is that better?
Calm down.
Now what do we need to do, guys? Yeah, there's multiplication here. I need to get rid of that, so I'm going to divide by negative 2,078.72.
We're putting some work in this problem.
Mm-hmm. That will cancel, and this is going to get me cosine of C. So if I do that in my calculator again, I'm going to do negative 681.49 divided by negative 2,078 point, what is it, 72?
Yes.
Do we get that right there? Again, that's cosine. I don't want cosine of C. I actually want C. So we're going to do second cosine of second answer. $70.86. We agree with that? 70.86? So if I go back up here, fill in, angle C was 70.86, and then we have to do all that do all that process one more time?
No.
What?
No.
Why?
Because we can just add
Oh.
63 and 70.86.
Yeah, now I've got two angles, right?
Yeah.
If I know two, then I know the third. Don't do the law of cosines a whole nother time. That'd be brutal. So 180 minus 63 minus 70.86, that'll get you angle A.